Hello and welcome, guys, to session 7 of our introduction to the C++ programming language. And we're going to be going over something that you'll see within C++ programs as struct. So a data struct is basically, or structure is basically when you create a group of variables in a way. Think of it as that way. Let's say you have a group of measurements, right, for a kitchen here, and the width is in feet and also in inches. So it contains both units of measurements. You'd want to keep them together as part of the width. But if you were to, give them all each their own variable, then you end up with a ton of variables and it gets messy quite quick, right? So a struct is a way to define the sort of structure that looks like this, right? You can use it for other things, but basically you define a standard, right? So if for measurements, we always expect them in feet and inches, then you create a grouping of feet and inches and you can store that within the actual width, okay? So the best way to understand it is to actually see an example. So I'll take you through it. I'm going to be writing a program that calculates the area of a room, so the kitchen that we're looking at right now. And it does that by multiplying the length and the width. And crucially, each one is made up of two measurement units being feet and inches. So that's going to be the complexity here that we want to tackle. So let's get into it. We start with our preprocessor, include string because we're dealing with input output, and then the namespace declaration using namespace standard. And then we can get into writing or defining our structures before we even get to the main function. We actually do this beforehand. So struct measurements, and then we define it. Say we have it's as integers, and then inches as floats. So right off the bat, we know that any sort of measurement that is defined within the program is going to follow this standard. It's going to have feet being integers, and then it's going to have inches being float. Okay. Then we can define another structure for the room to represent the kitchen. And the room is going to have both length and width, right? And these are going to be measurements. So you can think of it as the data type, as a defining data type. That needs to be singular. We define it as singular up here. So as you can see, we are already encapsulating, or we're already making use of that first struct in a second struct. So basically, this length consists of a measurement, and a measurement consists of both having feet and then inches. So already we are using this here. So you can see how handy it can be right away. We haven't even started to write anything in our main function yet. So let's get into it. Integer main, as always. Then we return 0 towards the end. Cool. Now let's think about saving these values into some structures. So let's define our room as kitchen, and then let's store the length. Okay, so kitchen length feet equals 12, and length inches equals 6.5, and store kitchen with feet equals 10, and kitchen width length equals 5.5. So then we can calculate the area. So area is going to be a float. Area is equal to, and it's going to be total length times total. Let's define those here. Floats total length is going to be equal to the kitchen length in feet plus kitchen length in inches. Of course, we have to translate inches to the feet. 12 inches make up 1 feet. And then we do the same for the width. So let's replace that. Okay, cool. So then we can actually print out the result area of the chip is. Let me fix that. And let's see that in action. And there you go. So the area of our kitchen and room is 131.165. And that's exactly what we were expecting. So I hope you can see how we can set values using structures. It adds another dimension really to our variables, and we can also access them. So we can set them right separately. So we're setting the feet here. In here, we're setting the inches, and then you can access them separately and use them throughout your program. So it's another way to organize your code and make it more robust. So that's it for session 7, program 1. Thank you very much.